Welcome, everyone. First, a brief history here. Microtrac has experience in online dynamic image analysis, including sampling systems and control, since 1987. That's when the first analyzer was put online at a granular fertilizer manufacturing plant. Since then, over 40 Parton online image analyzers have been installed on processes of all types around the world. There is an evolution in this. The photo in the lower left shows the original installation in 1987. There's a unit next to it from 2001, and today's current Parton 3D Pro model is shown on the right. 3D designates that it uses the 3D algorithm for image analysis calculations that was invented and patented in 2009, and it's exclusive to Microtrac. The Pro designation is that it's a process or online instrument. This slide reviews some of the key benefits of online particle image analysis. Important benefits to online analysis and control include the following: improved quality and/or productivity, normal process surges like changes in feed material properties, local control loop responses to changes cause wide fluctuations in quality and productivity if control action isn't taken quickly. Manual sampling and lab analysis is manpower intensive, takes time, and is subject to representative sampling error. Real-time control minimizes fluctuations. Faster startup. Reach process equilibrium faster with the opportunity to minimize surging during startup. Less downtime. Respond quickly to minor process problems like screen clogging, pump leaking, surge tank overflow to save the process from catastrophic shutdown. It also avoids control operator error when an online analyzer result is input directly to automated feedback control loops. Here's a chart showing different types of process control protocol. On the left is a diagram showing what's typically referred to as inline or in situ. It's almost impossible to get a probe inline in a tank or a pipe that can sample a point in that process where there is always a representative particulate sample. And that's a good segue to our second protocol listed here, and that is the one that Microtrac uses. We have an online sampling of particulates. Here, sampling systems are applied to representatively sample a particulate process stream over a short period of time and divert the sampled stream to the particle analyzer. And there are well-established representative particulate sampling systems which can be applied to various types of streams depending on the process and the sampling point. And last, there's the at-line sampling, which we've already discussed as being the least efficient for optimizing control. It includes manual sampling, followed later by lab analysis. This slide points out the unfortunate problem with most manual sampling and control of processes. We see here fluctuation in feed rate to a unit operation. It could be a milling circuit, a granulator, a crystallizer, etc., as tons per hour versus time. The surging is usually a result of fluctuations in one or more characteristics of the material being fed to a unit operation. Maybe mineral hardness, maybe filter cake moisture content. This causes a change in particulate parameters downstream, be they size, sphericity, or some other particle morphological parameter. The big control problem is the time expended and the manpower expense, and resulting long out-of-control periods resulting from manual sampling and control. Most simply put, it's the biggest problem is too much lag time between the need to make proper process control setting changes to minimize fluctuation in both productivity and product quality. In this slide, we see large fluctuations in feed rate and ultimately the feed rate far above the maximum out-of-spec range long before the next sampling time would take place. Note circled point on chart. The next slide illustrates the improvement to be expected using automatic continuous measurement and control. Here's a graphic example of one of the many advantages of real-time process control. Manual sampling and analysis in the lab takes much more time and manpower than does real-time measurement and control response. The black line sinusoidal trace in the above tons per hour versus time graph shows wide surge fluctuations because of slow, usually several hours, manual sampling and control response. Online measurement and control can affect control response to changing conditions every 5 to 10 minutes. That length of time, including sampling, long enough to measure a representative sample, which can be much larger and more representative than a manually drawn sample. The blue trace above represents typical improvement in process stabilization with real-time control. And the distance between the old minimum production rate and the new minimum is the productivity improvement. We'll go through 2 slides on particularly good applications for the Partan 3D Pros. The first group listed here is all traditional sizing applications where particles deviate significantly from sphericity. The 4 major categories are listed below: cylinders, spheroidal particles, rectangular prisms, and rough surface particles. The Partan 3D unit measures all 3 dimensions from which all the shape parameters can be calculated. The first category, cylinders like pencil shapes, get both dimensions measured. The second category is spheroids, which can be looked at as systematically misshapen spheres. We have on the left an oblate spheroid, flying saucer shaped and very similar to a pharmaceutical tablet. And to the right, a prolate spheroid, football shaped, similar to a pharmaceutical caplet. The third category is rectangular prisms. Here the 3 major axes have 3 different dimensions, which are all measured and reported, and from which all the shape factors are calculated. And the volume of each particle is calculated as the product of length, width, and thickness, which provides a much more accurate volume distribution than the equivalent spherical diameter as reported by 2D image analysis, and overall more accurate size and shape data. The fourth category is the roughness or jaggedness of the particle surface, which affects powder flowability, compactability, and packing density. The second category of applications for the Partan Pros are those traditional sizing applications which are finding that they would also benefit from shape analysis. The Partan was originally developed by a team working in a granular fertilizer industry. The granules need to be very spherical for consistent leach rate of the chemicals into the soil. Next on the list, the frac sand application recognized the need for shape measurements as early as the 1960s, when manual optical microscopy was used to quantify the sphericity and the surface roughness of frac sands, or proppants. The frac sands have to be smooth and well-rounded to allow free flow of natural gas through the hydraulic fracture. Next, stone aggregates used in highway construction need to have aspect ratio controlled in a number of different size ranges to achieve proper packing in the roadbed. In the coking process, shape needs to be measured for optimum packing in iron making, and similarly, sintered iron ore pellets need consistent size and sphericity for good packing and even melting in a blast furnace. Reflective glass beads used in highway coatings are optimized for performance when they have high sphericity, transparency, and curvature, a shape parameter not measured by other image analyzers. Microtrac has a long history of controlling fertilizer manufacture in real time. This is a typical granulizer fertilizer manufacturing flow sheet. There are now about 20 part-on online systems controlling fertilizer plants. In the upper left is the feed to the process. Granular fertilizer needs to have a narrow size range, about 2 to 4 millimeters in diameter, and the granules have to be very spherical in order for the product to have as consistent a dissolution rate into the soil as possible, which in turn optimizes the growth process. At the head of the process, a high-temperature chemical melt is fed along with a recycled stream of milled granules from the oversized screen. Some plants have more than one partan online. This one illustrates the use of one to measure the size distribution of the stream from the cooling drum to control the feed constituent proportions and the rate to the granulator, and also a unit measuring sphericity and size of the final product to control the cooling and smoothing drum operation. Unlike most online analyzer companies who use third parties, Microtrac offers complete sampling system and analyzer design, manufacture, and installation. There's been a continuing evolution in design and models of online analyzers since 1987. You'll notice this in some photos of older installations later. The newest addition to the line is a suspension system while still offering the dry systems. For sampling system design, Microtrac engineers meet with customers to get plant drawings for possible sampling points and type and size of samplers. Then they design the systems and procure parts and assemble the equipment, get customer approval, ship and install the systems on site. Material options include mild steel, stainless steel, Titan, and special epoxies or other durable surface coatings for harsh environments. And to date, all sampling systems installed have been custom engineered by Microtrac. Here are the current incarnations of the 3 dynamic image analyzers that are the online units. In the upper left is the Partan 3D Pro, in the upper right the Partan 3D Maxi Pro. These are both dry analyzers, each of which offers the patented 3D mode of measurement. In the center is the newer Partan SI Pro, which is Microtrac's first online wet suspension image analyzer. Check the Microtrac.com website to see specs. There are various size ranges available. In general, the Partan 3D Pro has ranges for smaller particles than the Maxi, and the SI smaller than either of those. Here's a little schematic of a single point sampling design. The gravity drop product chute on the left is sampled at point 1, and the sample falls through the Partan, where all the particles are photographed digitally and stored in a video file, which is analyzed for sizes and shapes. And multiple sampling points can be multiplexed to provide alternating samples to one analyzer, as shown in the next slide. And here multiple points are multiplexed, sampled, and measured alternately by one analyzer. This is an example of a Partan 3D Pro being fed dry sample from a pipe sampler with the return stream going back into the process line. This is a photo of a cup sampler on a process sampling fine granular powder, which is being fed to a dry Partan Pro analyzer below. The above slide shows features of the Partan Pro software, which are particular to online use. Above the size distribution data graph, there's an overlay pulled up used to assign control of various online process conditions to the samplers, vibratory feeders, and camera. Here again are software features used online. The trend results give information analogous to a trend chart recorder, a view of any size or shape parameter value over time, used by control room operators to anticipate any upcoming problems. Except for image analysis, all other online particle characterization technologies report only one parameter, which is size as equivalent spherical diameter, and they do not measure every particle individually to get high resolution, as image analysis does. This is the set of 32 parameters that Microtrac reports for its product line. Rather than go into each in any detail, I'll describe in 4 general terms what they measure. First, of course, is size. 15 different size measurements of each particle in various diameters, lengths, widths, thicknesses, and more. The last 3 columns are shapes of various natures and are generally expressed as ratios of size parameters. The 12 form factors include a number of different parameters that indicate how closely the particle is to being a perfect sphere, or various aspect ratios of the particle. Surface roughness parameters are just that. 3 different parameters can indicate the roughness factor of the particle surface. Other specialty parameters report the overall light intensity coming through the particle and the curvature of the particle as a gradient of light intensity. Just to let you relax a minute, don't be overwhelmed with all these choices. Only a few will be used, depending on your application and problems you need to solve. And the Microtrac support team is always there to assist. Only one size is usually chosen, along with 1 or 2 form or surface roughness parameters. The many choices exist so that you can be provided with the flexibility to optimize your particle characterization protocol. Here are 4 screenshots displaying some important features of the image analysis software, whether in a lab or an online instrument. Starting in the upper left is the analysis results display. Up to 6 different parameter distributions can be reported here, or overlays of 6 different analyses for one parameter for comparison purposes. Next, going clockwise in the image file display, all images in the saved video file can be displayed, sorted on any parameter, and a search query can be made to isolate particles within limits of various parameters to create different classifications of components within the total sample. The scatter diagram can be used to also create classifications or compare 2 different parameter distributions against each other. At the far left is a list of all parameter values that can be called up for any particle in the saved video file. And the video file can be remeasured any time under a different analytical set of conditions than it was originally run under. This is a great tool for method development. 2 of the 3 Microtrac online analyzers can measure in the 3D mode for new and much more accurate results. 3D image analysis is available, patented, from only Microtrac. First, the 3rd dimension, thickness, is measured in addition to length and width. Thickness is a very important parameter to measure for platy particle types. And much more accurate size measurements can be made when considering all 3 dimensions rather than only 2. This means that shape measurements are also more accurate, as most of them are calculated from the ratios of size measurements. And in 3D mode, individual particle volumes can be calculated as the product of length, width, and thickness. And finally, a new sieve parameter algorithm uses 3D data directly to calculate and report the correct historical sieve data as it was reported before, without the need to go through a tedious correlation function measurement and calculation. This is just a short list of some well-known companies which have partans online measuring and controlling their manufacturing processes. Now a total of over 40. Uralkali, Hydro, and PCS Phosphate are all fertilizer manufacturers. Sanofi Aventis is, of course, a large pharmaceutical company. Cargill is in agricultural commodities. Henkel, consumer products, and they're measuring a polymer superabsorber. Sudszucker is a sugar company, and Kraft, of course, makes many different food products. Topaz is another polymer application. On this prototype installation in 1987, the analyzer in the left-hand photo is analyzing the sample from the collection cup being elevated from its collection point shown in the right-hand photo. Here are examples of preliminary engineering drawings made by Microtrac engineers for one custom conveyor belt sampling system which will follow through to installed use. And the final installation drawings are shown here. Photos on the right point out the process where the sampler will be located in the actual plant. The installation is done by Microtrac and all drawings given to the plant maintenance department. Note also this is a high temperature process requiring insulated housing. And here's a short video of that conveyor belt sampler doing its job after it was installed. Here we see the conveyor belt feeding material towards us, and as I start the video, we'll see the sampler go over to the left and then cut across the stream from the conveyor belt and send the sample down to the partan below it. There's one cut, and the sampler will come back and cut the stream again, and that'll continue essentially the whole time the process is running. The photo on the left shows a feed hopper dropping sample onto the parton vibratory feeder in a KCl plant, potassium chloride. And on the right is a shot of the camera with lens cover illustrating the dusty environment. The lens cover can be easily cleaned or replaced, requiring no process downtime. Both a narrow size range and high sphericity of the KCl granules have to be controlled. This is a crushed material, so changes to the gap in the crusher can improve sphericity, and changes in feed rate can maintain a narrow size range. Here, in a calcium ammonium nitrate plant, on the left is a custom cup sampler path to go around the cooling drum below the sampling point. In this spray cooling spheronizing process, temperature, nozzle pressure, and rotating nozzle RPM are controlled to avoid agglomeration during drying and to maintain size and sphericity control parameters. The photo on the right shows the Partan Pro where a hinge had been broken on the measuring compartment door. And here's the analyzer with the door repaired, the only repair service ever performed on that unit 18 years after installation. This is a photo of the inside of the measuring compartment of that same analyzer, showing the robust ruggedness of the instrument operating around the clock under such severe plant conditions. The left photo shows the cleanliness of the glass plate separating the sample zone from the camera as a result of a clean gas purge across the inside of the glass. On the right, all the cabinet wiring required when this instrument was installed in 1993 is shown. Now only one optical or Ethernet cable replaces all the various communications wiring in this photo. Another example of Microtrac engineering design evolution as new technologies become available. Here's a photo of an online pipe sampler used in a plant processing laundry detergent. A simple design, but it works. Here's the commercial version of a Par-10 3D Pro and Maxi Pro. One communication cable to transfer camera photo, control sampling, and feed rate. Blue tubes are for purge air, for keeping all optical surfaces clean. This is a Par-10 Maxi Pro measuring iron ore pellets. Here, size and sphericity need to be controlled. During the iron ore green balling process, the balls tend to grow in layers. If the temperature in the sintering furnace gets too high, the layers start to separate. And the layering can be controlled by changing various parameters in the balling process: rotational speed, binder addition, and feed rate, for example. This is an open view of the Par-10 SI Pro combined sampling, dilution, and analysis sections of the wet suspension offering, our new offering this year. The top section is where the suspension process gets sampled and diluted if necessary. The sample then goes to the mixing chamber, from where it flows down through the measurement area, through a glass flow cell, where a digital camera combined with strobe lamp produces the video file of the particle images for analysis. Just to summarize our key points here, Microtrac has experience in custom online dynamic particle image analysis from sampling system to analyzer to control room since 1987. Microtrac engineers design, manufacture, and install all systems. Over 40 systems are installed and operating around the world. 2 dry dynamic image analyzers with patented 3D mode of analysis, the Par-10 3D Pro and the Par-10 3D Maxi Pro, plus a new suspension Par-10 SI Pro analyzer are shown below. Up to 32 different size and shape parameters are measured and reported, and online analysis and control increase productivity and quality, reduce downtime, and minimize startup time.
Thank you for checking out our on-demand presentation. We hope you found the content valuable. If you would like to see if an online dynamic image analysis system is right for your quality control process, please email jason.noga@microtrac.com to arrange a meeting with a technical specialist. And for more information on our entire suite of particle analysis solutions, please visit microtrac.com today.